So question 3, the following diagram shows a triangle ABC and a sector BCD of a circle with center B and radius 6 centimeters. The points A, B, and D are on the same line. The area of the triangle ABC is 3√3 centimeters squared. So question A says find the angle of ABC. So for triangle ABC, we have this side 2√3, and we have the side 6, and this angle between them is what we're looking for. So what we're going to do is we're going to use the area formula 1/2 AB sine C, using those two sides to find our missing angle. So we're given that the angle we're missing, we're given that the area is 3√3, and our two sides are 2√3 and 6. And the angle we're looking for is the one between these two sides, so we can use this formula. And then we'll go ahead and simplify the right-hand side. So we have 3√3 is equal to 6√3 times sine C, because 1/2 times 2√3 times 6 is 6√3. And then to get that sine C by itself, we can square root both sides, or not square root, divide both sides by 6√3. And so we get that the sine of C is equal to 1/2, because what happens is the 3√3 divided by 3√3 will cancel to 1, and so we're just left with 3/6, which simplifies to 1/2. So if we take the inverse sine of both sides, that turns into our angle C is the inverse sine of 1/2. So going to the calculator, C is 30 degrees. So there's our first answer, 30 degrees. For part B, it says find the length of arc CD. So arc CD is part of the circle with center B. In order to find this arc CD, we're going to need to figure out what this angle is. In part A, we found out that this is 30 degrees, and because that 30-degree angle is supplementary with the angle we're trying to find, that means that angle CBD is just 180 minus the 30 degrees. So that angle is 150 degrees. And from there, once we have the angle, we can just use the arc length formula. So our arc length formula from the notes at the top is 2 pi r times theta divided by the 360. So 2 pi, we're given that the radius is 6, and the angle that we care about is 150, so 150 over 360. And plugging that into the calculator, we find that the three significant figures, we're looking at 15.7 centimeters for the length of arc CD. Don't forget your units there. For part C, it says find the exact area of sector BCD. So that's the part of the circle. We have that area, we have that angle 150 degrees. And so we can just use the sector area formula also from the top, which is just pi r squared. That would be the area of the full circle, times just the piece that we care about, so theta over 360. So in this case, it's pi times 6 squared times 150 again over 360. And when we do that, we get 47.1 centimeters squared. And that's question 3.